Hey, welcome to Java Stack Engineering Forum. We've got, some .NET people and Donuts.js people here as well. The main reason is we're talking about stack integration strategies, which the patterns really apply to all the stacks. We've spent quite a bit of time over the last few months comparing different strategies, and so the purpose of this presentation is to demonstrate what we've found, what we've discovered, some pros and cons and patterns and anti-patterns that we've identified. So our objectives today are to review some terminology associated with service-oriented application architecture. These are terms that we use on a regular basis, and just so to make sure we're all on the same page as to what we mean when we say certain things. Identify the primary components of a service-oriented application. Compare the, let me put this on, actually play this, that'll be better. Okay, identify the primary components, compare strategies for integrating the front end and the back end, and then see each strategy from a configuration standpoint. So the sample code is, you're not expected to run and build this. We don't really have time for this to actually be a lab today. But the sample code is out on in Stash. The primary code that we'll be looking at is in the application service. There will be some things in the front end application as well, but mainly it's just flipping switches. But that's where the code is. There's some anyway, that's where it's at. But as I said, you're not expected to run it today. We'll just kind of walk through it. So terminology-wise, a web service is essentially just an application that provides an API of resources. Those resources are consumable over the standard protocols of the web. And those resources could be data, it could be assets, or it could be some capability that you want to provide in the case of an RPC API. So so the resources are assets, data, or capabilities that are consumable by your application or by other applications. The resources could be assets and data that could be static or dynamically produced. So most of the time we talk about the resources being dynamically produced, but sometimes we serve up static data through web services as well. Ultimately, every web application is essentially a service. It's just a matter of whether it's intended to be consumed by a user or whether it's intended to be consumed by an application. In service-oriented architecture, we use the term enterprise web service to describe a web service whose API is reusable across more than one application. And it may be scoped for reuse within a solution, a portfolio, or the enterprise. So it may have a very narrow scope or it may have a very broad scope, but the point is it's intended for reuse. Enterprise web services do not typically have a front end, and we actually discourage enterprise web services from having a front end. And for that purpose, we've defined what's called an application web service. This is designed to have a front end. It is a web service that is tailored for the needs of a single client application. It collects and transforms resources from other sources for application-specific use. And that's, so the application web service does have a front end on it. We've used this diagram before. Over here we have our front ends, which could be browser or a mobile client. Behind the gateway, on the server side, we have the application service. So this is the area that we're talking about today, as well as the front end, but mostly we'll be talking about the application service. Enterprise services belong back here. We discourage them from actually being fronted directly by a front end. They could actually, though, be fronted by a mobile client because that doesn't have the CORS issues, the cross-origin issues that browsers do. one of the main reasons for having a web application service is to, it's not the only reason, but one of its primary purposes is to help solve the CORS issue. Other reasons to have it is to transform and any data that's coming in from these enterprise web services in some application-specific way so that it makes sense to the front-end application that's consuming it. So we have our data stores, our enterprise web services, the application web service, and the clients. So that's our service-oriented architecture. Let's talk about application architecture, the application itself. In this case, we're just talking about the orange bubble here. The application web service is also called the backend. It provides an API of resources for application-specific consumption. The application front end is an end-user interface, such as a browser or mobile application, and it obtains its resources from the web service. Now there's also, depending on the nature of your app, and very often there is a front-end service whose sole purpose is to serve up the application's front-end assets, and we'll be talking about that today. So that is typically a Node application because you're generally dealing with the JavaScript front end, so it makes sense for that front end service to be a Node.js application. And it may, but not always, it may perform server-side rendering, although many applications that I see don't actually use that. That is an option. Because it's running on Node, it has that ability to do that. And it may be in other cases be integrated with the application web service, and we'll compare and contrast some of those different patterns. When we talk about integrating the application web service and the application front end, there's some goals that we have. First is to preserve a separation of front-end development concerns from back-end development concerns. We don't want to mingle those two together or couple them too tightly. They are coupled by very nature. If you've got a client and a server that have one-to-one mapping, you've got a client that is intended to access one service, and that service is intended to be served to service the needs of one client. But you still want to have a separation of concerns. So functionally, they are bound together, but the only API that really should exist between them is HTTP. Other goals are to allow the front end and back end components to be developed concurrently, so that whether you have the same developer developing the front end as the back end, or whether you have a different developer on the front end and a different developer developing on the back end, that development can proceed concurrently and at the same rate or at different rates depending on just the needs of the application. And also to allow front and back end components to be integrated easily. So that being the case, there are a number of strategies that we've identified. There's probably a lot more than this, but these are some that we've identified. One which is in use by some applications is where a combined build and deployment. This is probably our least recommended strategy, and we'll discuss some of the reasons why. Another one, which is kind of an increasing separation of concerns, is you have separate builds, but they're still combined when they get deployed. And then a third strategy is to have a full separation of the builds, so you have completely independent builds and completely independent processes for the front end and back end. When you have those independent processes, there are different ways to integrate them. So when you have separate deployments, one way to integrate them is to integrate it via the application service, where the application service effectively proxies the front end assets. The other is kind of a flipped scenario where you integrate it via the front end service. In that case, the front end service proxies the API calls to the back end. And third, integration via cores. So you configure your backend application with some CORS headers so that it can get past the cross-origin restriction in the browser. And finally, a fairly new option that's available for both cloud and non-cloud apps is to use F5 context path routing. So all four of these are ways of your application is fully separate in processes. You've just got different configuration that supports these. So why so many options? The reason, first of all, no single strategy fits the needs of every team. What may work for one team doesn't always work for the others. Every developer, every development team have their own preferences and their own biases, which are perfectly fine. It's a matter of what am I willing to live, what annoyances am I willing to live with, and what am I not willing to live without. So yeah, no single strategy fits every team, and no single strategy fits the needs of every application. What might make sense for a small application that may not undergo a long life cycle may not make sense for an application that's going to be of a broader scope and undergo a lot of maintenance cycles. On the Stack team, we can offer guidance, but the choice ultimately belongs to you as the solution team. So and that's because we don't know your team, your needs, your use cases as well as you do. So we can present you with the options, and we can guide you and present the pros and cons, which is part of what we'll do today. But ultimately, the choice needs to belong to you. And just to be sure, your application strategy can be changed at any time with just a little bit of configuration. So if you decide to go down one route and you decide that's not the right route for your application, you don't have to completely start over to change. There's some simple configuration switches that you can make to adjust your strategy. So first, let's cover the combined deployment. I mentioned there are two combined deployment strategies. One is where you have a combined, the builds are combined, and then they end up getting deployed in the same process. The other is where the builds are still separate, but during the build process, the ALM process, for example, would copy those front-end assets into the back-end artifact. So anyway, that's how it happens, and then it gets deployed as a single process. And in that case, you have the front-end assets living as just a resource within the back-end application. And I do know of some applications that are doing this strategy. You simply define a mapping that says anything that's not already mapped is essentially my front-end application. Those assets get delivered directly from the web app or from your application service, and then API calls are then made to the same origin. So you don't have the CORS issue in this case. There are some advantages, and of course there are some disadvantages. As I mentioned, this is probably our least recommended strategy. We do support it, but it is probably our least recommended. And the main reason is it has the most disadvantages of any of the strategies. The advantage is that it may, I'm not saying it will, but it may simplify development when the same engineer is developing both the front and the back end. And what is often seen as the big factor for this one is that you only have one service that needs to be managed. But you have a number of disadvantages with this. Separation of concerns is only weakly enforced because your build and your deployments all end up ultimately in one place. So you still may have a separation of concerns, but there's not really a whole lot to enforce that. It does tend to complicate development when the same engineer is not developing both the front end and back end, because in many cases, we have developers putting these both in the same repository, and that having both the front end and the back end, which are essentially very different concerns, in the same repository tends to it causes some development complexity as you iterate through that. And even if you have them in separate repositories, the fact that ultimately they still get combined, you can't have your back end being serviced up by different versions of the front end. They all end up in the same place. So it does have a tight coupling of the front end build process to the back end build process, and that results in reduced continuous build flexibility. Particularly if you have the front end assets living in the same repository as the back end, we especially discourage that, because primarily the ALM, your node process that builds the front end has very different needs than the Maven process that builds your back end. And when you're having your Maven process kick off the node process, it's not going to be able to get all of the information that it may need. For example, it may require a special node version of Node or NPM in order to build. So those are some things the ALM team has run into. And so that's one of the reasons why we discourage the combined build process. The combined build process also couples the front-end deployment to the back-end deployment. So as I said, this one has the most disadvantages, and it's the one that we would discourage most people from using. Combined deployment, this is slightly better. You don't have a combined build in this case. Your front end has a separate build in Anthill. Your back end has a separate build in Anthill. But the ALM team sets up a dependency between your front end and back end projects, so that when your back end project is built, it copies out the front end artifacts, or the front end assets, and copies them into the back end artifact. So it's a little bit better because at least your build processes are fully decoupled. So you do have an independent front end and back end build system. And because they are completely decoupled, you have some independent front end and back end development. You still only need to manage one service, and this, like the other one, it may simplify development when the same engineer is working on both the front end and the back end. So if you want to have a single process when you deploy, if that's all you care about and you don't need isomorphic development, then this may be okay for you. It's much easier for ALM to support. It's easier for our team to support, but it doesn't have the strongest separation of concerns, because separation of concerns is only moderately enforced, and you still have a tightly coupled deployment between the front end and back end. You can't have different versions of your front end going against your back end because they get deployed at the same time. Let's just look at some examples. So I've got these two projects checked out, and I'm going to mainly look at the back end. So on that, let me increase the size here. Okay, so we have several branches on this. If you just type git branch -lr, it will show you all of the branches that we have. Each branch represents a different integration scenario. So we have a combined build branch, a combined deployment branch. Master represents...
Robert, highlight those so we can see.
Okay. Okay, yeah, let's just dim the lights.
Just highlight that whole one.
Okay, all right, let me highlight the first one. So there's the combined build branch, which I mentioned. Combined deployment. Master represents the state of the repository without any integration having been attempted. There's a branch for separate deployments with backend proxying the front end. separate deployments with front-end proxying the back-end, and separate deployments with cores. So each one of these branches just shows a little bit of configuration and the different configuration in the application service, depending on how you're going to integrate. And as you'll see, the difference in integration is really quite minimal. So right now I'm looking at the combined build, and let me just diff that one to well, we'll see. I'll just point out the highlighted differences. So with an Angular app, or really any responsive app front end, or single page app front end, you need to have some routing. Let me increase this as well. Why don't I know? Okay. So for Java Stack applications, we just pull in this configuration, single page app, MVC configurer. It just makes it so that if you do a refresh on a route that is only understood by the front end, that it will still serve up index HTML. And that's just to handle refreshes. So that's one piece of configuration. Now, development-wise, there's just a little bit of configuration in there. Let's go back to... So we just need to point out to where the front-end build assets are. So this just makes it easier so that you don't have to constantly repackage your application every time you want to run it. Spring Boot, this is obviously going to be different if you're a .NET developer, but with Spring Boot, you can use Spring resources, static locations, and just point it to the location of your static resources. And you'll see in a lot of the integration scenarios for Java Stack, we use this a lot, particularly for local development. I can give this any URL that I want, and it can be an HTTP URL, it can be a file URL, and it'll just use it, whatever assets happen to be there. And it becomes very convenient in the development scenario, and in one of the integration scenarios, it's also pretty useful. Now, however, in the combined build, yeah.
So one of the things we ran into doing this sort of an integration is having Spring Boot dev tools hot reload these assets. Does this take care of that?
Yes. So if you use static, let me think. Yes. So particularly if it's outside the project file, for example, I'll, even if I have static assets in the same repository, I'll just symlink to a public folder or something. But anyway, you can use this, and that will allow you to not have to redeploy your application. So all you have to do is just hit refresh in the browser, and it'll give you the new asset. So it's pretty useful that way. Okay, so now in the combined build scenario, your biggest configuration is going to be in your POM, and it's this big long profile here that you have. I will increase the view so you can see what it's doing, but this is one of the reasons why we kind of discourage this. So first of all, you've got to configure Maven to potentially clone your front end and then run a build on it and do everything that the NPM build would normally do. You've got to configure Maven to do that. So that's not trivial configuration. It's once you understand the Maven plugins involved, it's not too difficult, but you can see it's quite verbose. You have to define an npm install process that runs that. You have to define a Bower install process and then a Bower or an npm run build. And then finally, you have to run the Maven Resources plugin to tell it where to copy the assets. And if Maven is doing this, then ALM has no control over which version of NPM you're using. So if they're going to use NVM to control the version of Node, you've got to set those environment variables yourself. They can't do it. The ALM team can't do it for you. And so, as I said, it's not our primarily recommended strategy. So that's where your major difference is right in the POM. So let's go back to the presentation. Combined deployment looks pretty much the same, just without those POM changes, because all the integration, rather than Maven doing the npm install and the Bower install and copying the resources over, the ALM process is doing that behind the scenes, so your application doesn't have to do that. So let's move on to the next scenario, integration via application service. In this case, you have two separate processes in this, as indicated by half circles here. Full circle represents your application. The half circle represents a particular component of your application. So you have your application service component, which handles API requests. You have your, I meant to call this front-end service, but asset service, which serves up the assets. So you've got two separate processes. Your application service could be Java, .NET, or Node. Your front-end service or your asset service is typically just Node. I can't think of any reason why it wouldn't be anything but Node. Let's talk about some of the advantages and disadvantages of this one. Separation of concerns is strongly enforced on this one. It has a fully independent build process and deployment process for both the back end and the front end. And for full stack engineers, people that are used to working on both sides, front end and back end, this one has a lot of attractive features because it simplifies development for teams that are primarily full stack, not specialized in the front end. It has a very simple proxy model because the front end assets are typically stateless. So when it's proxying these, it can be a really dumb proxy. All it has to know is just give me what's the location of those assets and serve them up. However, if those assets, if you're doing isomorphic development, this can complicate that scenario a little more, because in isomorphic development, they typically like it to be flipped, so that you can point your front end at any back end rather than having your back end pointing at a single front end. So there's a disadvantage in that scenario. So it kind of depends on the nature of your team and the nature of the developer that's doing this. And we'll look at this one as well. So I'm just going to, I'm here. So I'm going to check out the separate, I'll just copy this. I'm going to check out the separate deployments with backend proxy branch. Oh, oops. All right. I just need to tell it to ignore that front end directory. Oh, I thought I did. So checking out the separate deployments with backend proxy branch. So we don't, in that one, as you'll notice from the POM, it just got rid of all that extra POM stuff that we don't need there because it no longer has to do that special Maven stuff. The main class, you'll notice we don't need the single page app MVC configure anymore. That's because the proxying handles that automatically. So we don't have to have that. And the final piece is, let's show this. This is the main magic of this one going up. So for example, in this case, I'm pointing at a location in Cloud Foundry. So as I mentioned earlier, this Spring Resources Static Locations just needs a URL. It doesn't care whether it's a file URL or a HTTP URL. It can be a local URL. It can be something in Cloud Foundry. So as long as it's there, it just grabs those static resources and handles it. So this one's pretty easy from a development standpoint, but as I said, there are some disadvantages, so make sure that you understand what you intend to do with your application before you choose this option. But if you do this option and decide to go with a different option, as I said, it's just a matter of changing the configuration. So there's not a whole lot of configuration to do that. Just give it the URL to the front-end assets wherever they happen to be, and it's happy and ready to go. So let's talk about the reverse scenario. Integration via front-end service. In this case, it's very similar to the other one, except instead of the back end proxying the front end assets, you've got the front end proxying the back end API. So all API requests are proxied through the asset service to the application service. Implementation-wise, they're the same. Let's look at some of their advantages and disadvantages. Separation of concerns is still strongly enforced. You still have an independent build and deployment process. And if you have front-end engineers on your team, this is apt to appeal to them more, and it's probably going to make their job a little easier. So disadvantages, the proxy model is a little more complicated because it's proxying a stateful backend. So if you have WAM, for example, development-wise, that can be a little bit more tricky, but we have people doing this right now, and it's not that bad. So if you have a team that has front-end specialists and back-end specialists, this is probably apt to appeal more to your team. And in this one, I'm not really going to, in the interest of time, won't really look at the example. From the back-end perspective, there's really no change. The back-end doesn't care how the front end uses it. The front end just has to proxy, and depending on whether you have some, anyway, there's certain headers that the front end probably should ignore when it proxies, and then there's certain headers that it may need to rewrite, just depending on how it's implemented. Let's talk about cores, though. We've done a lot of applications are using this one as well. So CORS stands for cross-origin resource sharing, and CORS is designed to get around a security feature in the browser. In order to prevent cross-site requests or cross-site scripting, browsers disallow cross-origin requests by default. So when you have your front end living on one service and your back end living on another service, and you're going to be serving up resources from both, in order for the front end to make JavaScript calls to the back end, you have to set up your back end to allow those cross-origin requests. Otherwise, it will say, I don't know, this request is not coming from me, so I'm going to reject it. So the back end provides some configuration that allows those requests. There's several fields that it can supply. The primary one is I can allow requests from this origin. So for example, I can allow requests from localhost, or I can allow requests from userdemo.lds.org. The browser automatically, behind the scenes, does a pre-flight for you. It just makes an options request to get those headers, and if it sees those headers, the browser will let the request go through. But if it doesn't see those headers, the browser is going to reject it, because it's going to say, you're making a request from one origin to another origin, and I can't allow that because this other origin says I can't. So I'll show you what that configuration looks like. It's pretty simple to configure just to get started. But once you're done, you have to. But a production scenario, there's typically more that you want to do. So integration via cores, you still have a strong enforcement of a separation of concerns. You still have independent build and deployment processes, and it does simplify development for teams that consist of both front-end and back-end development, front and back-end developers. And you don't have any proxying of the front end or back end, so there's that piece of complexity, the proxy, that doesn't exist. Disadvantages, it can be tricky sometimes to fully configure CORS protection on the back end for a production lane. For a local lane or a development lane, you can just leave it wide open and you generally don't care. And for some teams, this has been a difficult one to handle, particularly if their front end and their back end are on different domains. So sometimes there's some additional configuration that has to happen to make the back end happy. So let's just look at a code demo of that one real quick. First, I need to check it out. So separate deployments with cores. So we'll look at application YAML first, since that's the one that's popped up. So in a typical production scenario, you're going to want to set your allowed origins. So there may be one or multiple locations, depending on how many. You could have multiple front ends, maybe hitting the same back end service. So, localhost, for example, and a dev instance. So you want to make sure you tell it which origins are allowed to hit that service for the browser's sake. Spring security will allow you to just say allowed methods ***, just accept everything, all methods, all headers. Generally, that's what you want for a web service, because you may have any number of headers or methods that need to get set. There may be some headers that need to be exposed to the front end, such as the CSRF token is a prime example. Allow credentials. This setting says that cookies can be passed. So the front end can get access to those cookies if it needs it. And then max A is just how frequently does the browser need to check for changes to this policy. So that's your typical production configuration or production-like configuration. But to get it working, all you have to do, let me switch out of this mode and go to So I'm talking mainly, at this point I'm talking mainly to Java developers. .NET developers, I'm sure there's a different way to enable it, but for, okay, why am I not seeing it? No, anyway, all you have to do is there's a course header or cross-origin header. If you put that on your endpoint, let me expand the view here. if you put this cross-origin header on your endpoint, it automatically opens it up for cross-origin requests. Now this does allow you to set all of those fields that I showed you before, but it doesn't accept expressions, so you'd have to hard code those in here. That's why it's preferable to set them in the properties file. But putting this annotation on the endpoint is a good way just to get started. Or if there's a, in the next scenario when we talk about F5 routing, in that case you'll probably want to use cores locally, and in that case just putting this on your endpoint is probably just fine. You don't have to do anything else. So, so enabling cores in a Java Stack application is pretty simple. In the front end, as long as you've got that enabled on the back end, the front end is able to make those calls, and it doesn't need any extra configuration. Okay, finally, integration via F5 context path routing. Both the Cloud Foundry and non-Cloud Foundry, this is available for both. Cloud Foundry has recently begun to support this. There's a lot of attractive features about this. You still have, both applications can be directly accessible. So your front-end service and your application web service can both be directly accessed via the browser without having to have one proxy the other. You don't have the cores issue. The main, what the F5 context path routing does is that it makes the browser, it tells the browser that both of these are coming from the same domain. Even though behind the scenes they're not on the same process, from the browser's perspective, they're coming from the same origin. So that is the most attractive feature about this. So from that perspective, advantages, separation of concerns is strongly enforced. You still have your independent build and deployment processes. It simplifies development for teams that consist of both front-end and back-end engineers. You have no reverse proxying. You have no course configuration. The only disadvantage is the local development, and it's, the only disadvantage is you just have to set up cores for local development, because locally you can't imitate the F5 context path routing. So locally you have to use a slightly different strategy than you would up in the cloud. Or you need to create a proxy in front of your application that essentially does the same behavior, that does the same thing as the F5 context path. But the easiest way is to just set up cores for locally. One thing that I've seen some teams do that lead to a lot of complexity is don't use WAM for imitating the F5 context path routing. Or don't use the WAMulator, rather. WAMulator, for one, you may have to use WAMulator for authentication, but don't use it to imitate the F5 context path routing. It gets really hairy, and it's difficult to configure, and it's, anyway, I haven't had a good experience with it. I don't know if anyone else has, but I haven't had a good experience using the WAMulator to imitate that. So, that's the end of the presentation part. I wanted to open it up to questions, but first, if you go up to integration point and just type in integration, this is, the second, in this case, option that comes up. This is where the documentation for everything that I've discussed today is, including advantages, disadvantages, and so forth. So in the time remaining, I'd like to open it up to questions and just see what you guys think, what questions you have about the different options. I'll pull up the presentation with the documents just in case we need to reference any of that. Okay. Yeah.
So this may be obvious to some people. Can you talk about some of the network architecture implementations of doing these different types of integrations?
Well, the F5 is the network architecture integration, if that's what you mean.
That's one way to do it, that
Yeah.
F5 is doing the splitting requests off, so it's hitting one process or the other process.
Yeah.
Part of what I meant was like if you're deploying your front end, if you could deploy your front end to a lower security zone than your back end, you may be able to push it out closer to your client.
Oh, yeah.
Therefore, if you're proxying from the front end to the back end, you may be able to get a better performance for your client in some way or another.
Okay.
Because it's closer and because it's already got a hot connection back to your service.
Yeah.
There's also, from a development perspective, that one in particular allows the front end to use just a mock service or a staged version of the service, and therefore the front end is less dependent on the application service in terms of how it works.
Yeah.
But they're just kind of different consequences for this from how the network and where the deployment can take place.
Yeah. Thanks. Those are all really good points, and they do kind of highlight what I would like to say is our recommended strategy. Whatever strategy you choose, the primary recommendation we have is have separate processes, because that gives you the most flexibility. If your front end is in a separate process than your back end, you can deploy, like you said, you can deploy that front end in a lower security zone than your back end, which is probably more sensitive. It just gives you a lot more flexibility in terms of build and deployment when you have separate processes. And even if you're not sure if that's what you need going on, you can start just having separate deployments, and it's still really easy to get going. What we found is that, let me just kind of go back a few slides here to the list of options. Let's see. All right. What we've found is this one, combined build and deployment, is the most complex. It's really easy on your local development box, but once it gets out into the build lane, just trying to get it to build, that's where you start seeing problems. And getting it out into your, once you get it built, it's probably fine, but having your front end and your back end co-located in the same process doesn't give you the flexibility that you may need as the application scales out. Any other questions or comments? That was a really good one, Aaron, thanks.
I have a question.
Yeah.
I've had to deal with web applications where the front and the back end were both fronted by Akamai. So that adds some additional complexity in terms of caching and proxy.
Yeah.
And I'm wondering if you have any suggestions for which one of these may be most appropriate, where your entire application is going to be fronted by Akamai on a CDN.
Well, I'd say probably either the F5 context path routing would probably be the easiest, or the cores in that case.
Yeah, one of the problems that we had was we had a front end application talking to a back end application. The back end application itself was also behind Akamai.
Yeah.
Because it had other APIs connecting, talking to it.
Yeah.
So it was complex.
Yeah. And that, either of the proxying scenarios, that's where you could have some loss of performance, because you've got either your back end or your front end having to go back out the front and get some information. So either of the proxying scenarios can have you could potentially have some performance issues.
Thanks.
Other questions? Okay, thank you. Please come see us. As I said, the document is out there, and the source code is out there. Please come see us if you have questions. As you're starting new applications and you're not sure which strategy to use, if you just start with any one of the separate build and deployment scenarios, as long as you have a separate build and a separate deployment, switching between one strategy or another, is pretty easy. But if you have to pull code apart, that's where you're going to find some pain. So, so just to recap, that either of the combined deployments, I would consider those as less recommended, or the top one not recommended. But any of the integration any of the separate build deployments are potential value to you, depending on the nature of your project. Okay, thank you.